This tutorial describes the basics of metadata, highlighting how metadata improves our ability to search for data while simultaneously enhancing its use or reuse. The value of applying metadata is then demonstrated using an image resource as an example. In today's digital age, data is everywhere. But how do we locate data of interest and understand how to use or reuse it? If we can't find the data, it may not matter how accessible, interoperable, or reusable it is. Metadata is the key to finding the data and unlocking its value. Metadata is often defined as data about data, or a resource, which is any physical or abstract entity that provides value. While technically correct, this definition doesn't capture its value or significance. Instead, metadata is better defined as deliberate, structured data about a resource. A box of cereal, a light bulb, or a medication are examples of physical resources, while digital images, an ebook, or data are abstract ones. Metadata provides context for a resource, enhancing its utility. It is not only essential in identifying and locating a resource, but it also establishes provenance and can help define relations to other resources. Metadata maximizes the utility of a resource to both humans and machines and can help determine whether the resource is interoperable with other resources. Many informaticists consider metadata of a resource to fall within three high-level categories: descriptive, structural, and administrative. Descriptive metadata describes a resource, its context, and identifying characteristics. Structural metadata describes how the pieces of a single resource fit together, and/or how a resource exists in relation to other resources. Administrative metadata includes information about rights, technical aspects, and preservation. People often operate under the misconception that the creation of metadata is a one-time, static process. In reality, metadata may be revisited at any time or many times to enhance its utility as additional information about a resource becomes available. If you create metadata after a resource is created, it's called retrospective metadata. However, you can also create metadata before a resource is created, which is called prospective metadata. Creating prospective metadata can have advantages, such as reminding you of aspects of the resource that need to be captured during the collection process. The structured organization of metadata is often referred to as its model or schema. These schemas can differ widely, from domain agnostic, such as simple Dublin Core, which can be used to store almost anything, to domain specific, such as Darwin Core, which is used to construct metadata for biodiversity resources. The ability to locate resources in a repository with any specificity and sensitivity is strengthened and enhanced by the metadata schema it utilizes. Therefore, using an appropriately constructed schema is essential to not only effectively locating a resource, but to also using or reusing it. Metadata expressed in defined schemas, standard vocabularies, and persistent identifiers allow for easy, unambiguous interpretation by both humans and machines. Now that we have discussed the basics of metadata, let's see how these concepts can be applied using a simple metadata example. First, we'll use a metadata example that you encounter every day. When you pick up a box of cereal at the grocery store, it has a great deal of information embedded: the brand, the expiration date, the ingredients, and the nutrition facts. All of this information is metadata, and like most metadata, it is of enormous use to the user. Now let's look at a scientific metadata example. Imagine you are interested in the following image file you found online. In the beginning, it may not be clear what this image is about, its significance, what you can do with it, how you would find it again, or how to relate it to other images. You decide to start small, using the simple Dublin Core schema as a guide. You capture the technical information on the image, the name, format, and web address. To provide disambiguation, you use standard vocabulary and persistent identifiers where possible. You can always revisit the metadata for refinement in the future. The metadata now provides you basic search capabilities. For example, you can list all the images in the repository. However, this is not very useful. Your search, although sensitive, will lack specificity. You can extend the metadata by adding descriptive metadata. You do a bit of additional digging and uncover that Rosalind E. Franklin recorded this image at King's College, London in 1952, so you update the metadata. Now you have metadata which enables you or someone else with access to your repository to use the descriptive metadata to search for and download the image in a more meaningful manner. For example, you may be able to look for other work by Rosalind Franklin. The query results using the additional metadata may even list files that someone else has deposited in the same repository. If you have their permission, you may be able to use these. You do some additional research and enrich the metadata to include descriptions, X-ray diffraction pattern of bDNA. You also locate the original source and language, and a related source for the image to use DNA and X-ray diffraction as the subjects in the metadata. Because you have been enriching your file metadata, you are now capable of building a collection of files related to the subject DNA in the repository. Finally, you uncover information about rights, licenses, and permissions regarding this image. This is crucial if you plan to publish or share the data in some form. In the future, you decide to write a review article on the causes of Down syndrome and decide to include background on DNA. You know you have the DNA structure images you added metadata to, but you perform a broader search in the repository and find images deposited by other researchers on DNA and Down syndrome. You even find images of key researchers behind discovering the structure of DNA and the causes of Down syndrome, Rosalind Franklin and Martha Gautier. Because you and other researchers applied granular metadata to the files, you were able to quickly locate a handful of images to include in your article. If your efforts were going to lead to new images or information being collected or generated, it would be smart to think about generating and collecting metadata prospectively. This example demonstrates the value of applying metadata to an image resource. It highlights how it improves our ability to search for data with specificity and sensitivity while simultaneously providing the descriptive, structural, and administrative information to enhance its use. It also provides an opportunity to recognize the discoveries made by two women pioneer researchers, Rosalind Franklin and Martha Gautier, whose discoveries were not adequately attributed in the past, yet were fundamental to our knowledge of unraveling the structure of DNA and the underlying causes of Down syndrome. We hope that you enjoyed this tutorial. To learn more about metadata, please see our Metadata Workbook for further information. It includes resources such as templates and reference material to help you along your metadata journey. Thanks for watching.